In lesson 19, we're going to be moving from equations into inequalities. So for the examples, it asks us to solve the equation or inequality, just as we are solving our addition, subtraction, multiplication, division equations before. Then we're going to graph the solution, which we'll see how to do. We're going to choose numbers from the set that's given to us right here that would make each statement true. So we'll see what that looks like. Okay, so the first thing we're going to do is we're going to solve the equation or inequality. So if we look at the first one, we have an equation since there's an equal sign. Since it's an addition equation, we're going to use the inverse operation, which would be subtraction. We're going to be subtracting the number that's on the same side of the equal sign as the variable. So in this case, we would want to subtract 6 to get y. Since we're subtracting 6 from the left side of the equal sign, we also have to subtract it from the right side of the equal sign. These two cancel each other out, leaving us with y by itself. And then 16 minus 6 is 10. So in this case, it is y is equal to 10. So when we go to graph this, we can number our number line like this. Since y is equal to 10, at 10, we would just put our point. Within that set, if we look, so that's how we would graph that y equals 10. It has to be right at 10 because of the equal sign. If we look within this set, we don't see 10. So since 10 is not in there, we would say that it does not match any of them. It matches none of the numbers from the set. If 10 had been in the set, we would list 10 as the match from the set. So now, looking at letter B, it's the same exact thing we saw in problem A, except instead of an equal sign, we now have a greater than sign. We're going to solve this the same exact way we would solve an equation, except instead of bringing down the equal sign, we'll be bringing down the greater than sign. So we'll still be doing our subtracting 6 from both sides, bringing down the y, and now we're going to be bringing down a greater than sign. So now it's y is greater than 10. So now when we number our number line, what I would recommend doing is putting 10 somewhere in the center. We could have done that up here. I don't know why I didn't. But typically put 10 somewhere in the center so we have room to work on either side of it. So we would do numbers less than 10 to the left of it, and then numbers greater than 10 to the right of it. So our solution says y is greater than 10. What that means is y would not include 10. It would be anything 10 or greater. So when we have that greater than symbol or less than symbol, what we would do is go to the number that it's referring to, and we would put an open circle there. That shows it does not include 10. However, it includes everything larger than 10, including anything in between 10 and 11. So any decimals, any fractions that would fall in between 10 and 11. We would then shade to the right, and we also shade the arrow to show that this continues on. So any number greater than 10 would work here, and it does not include 10. What's interesting is, too, this greater than symbol shows us which way to shade. So we're shading, since this is pointing to the right, we're shading to the right of 10. So now, something to take note of too, and I'm just going to make a little note of this up here. If we see greater than or less than this works for too, that means open circle. Let's see what we would do with the next one. So in the next one, once again, we have the same problem, except instead of equals than or greater to, we have greater than or equal to. So now I'm going to subtract 6 from both sides once again. Cancel my 6 out, my y comes down. Now my symbol, greater than or equal to, comes down. And 16 minus 6 is 10. So I'm just going to number the same exact way. In this problem, it says y is greater than 10, but it also says y can be equal to 10. When we have this line underneath, so either greater than or equal or less than or equal, that means at the number, we're going to put a closed circle. So I'm going to just add that up here. Greater than or equal, less than or equal means shaded in circle or closed circle. This is open circle. This is closed. And that's how it would be referred to on your homework and quizzes and tests. So now, since it is greater, that's pointing to shade to the right, so I'm also going to shade to the right as well, and I'm going to do my arrowhead. Now I do have to go back because I forgot the direction of choosing the numbers from the set that would be included here. So for letter B, y is greater than 10 means anything greater than 10, not including 10, would be in my list. So if I look at the numbers, I would see all of these numbers are less than 10, so they would not be included. However, the next set of numbers here, 11, 12, and 15, are greater than 10. So 11, 12, and 15 would be numbers from the set that would make this true. You can also plug in each number to kind of check it. Is 0 greater than 10? No. 1 greater than 10? No, and so on. So down here, then in letter C, I'm looking for any number that is greater than or equal to 10. So that means 10 or more. So again, these smaller numbers will not work, but 11, 12, and 15 would. Okay, so the first piece in this is solving the equation or inequality, graphing it, and again remembering if you have greater than or less than, so no line underneath, means open circle at the number. If you do have that equal sign underneath, so greater than or equal, less than or equal, that's a closed circle at the number. The direction in which the symbol is pointing is the direction in which symbol you will shade. Also, if you notice, this makes the greater than symbol, greater than symbol. This makes the less than symbol. So when we get to any problems with less than, we would shade that way. Okay, so let's try some more. These are with multiplication equations. So again, we're going to do the inverse operation. So since this is 3 times g, that means I'm going to divide both sides of the equation by the number that's next to the variable, so in this case 3. Remember, we showed division in an equation like this with the fraction bar. So over here, the 3's cancel each other out, leaving us with g. We bring down our equal sign, and 15 divided by 3 is 5. So on this one, I'm actually going to do it correctly, where I'm going to put 5 in the center and number up to the right, number down to the left. Okay, and since g is equal to 5, that means it has to be exactly 5. So at 5, I would put the point. I am going to just flip back a page for a second to get my set of numbers. So 0, 1, 4, 5. We're in the set. I'm just going to copy them over here so that I know which ones I'm looking for, and 11, 12, 15. Okay, so I'm looking for numbers in the set that would be equal to 5. So if you look in the set, 5 is in the set, so that would be the number that would make it true. Okay, so looking at the next one, once again, it's a multiplication problem. We will be dividing both sides then by 3. Same steps and process as in the previous piece. These cancel each other out. Bring down the g. This time it's less than 5. So I'm going to copy the same numbers onto my number line, making 5 in the center somewhere. This is less than, so remember greater than or less than means open circle. Greater than or equal to, less than or equal to means closed. So since it is less than, I will be doing an open circle at the number 5. It's saying that G, or the number, is less than 5. Notice the way the symbol is pointing. That means I'll be shading on my number line to the left, and the arrowhead as well. Okay, so now that we have it graphed, we have to look at the numbers within the set to see which ones would make this true. So we're looking for any number less than 5, and it does not include 5. So here's our 5. Anything less than it would be included to make it true. So 0 is less than 5. 1 is less than 5. 4 is less than 5. And that's where it would close. The 5 is not included because it does not have the line underneath. Okay, looking at the next one, divide both sides by 3. G is less than or equal to 5 in this time. And when I label my number line and go to graph, I have to look at my inequality symbol. I see the equal sign underneath, which means closed circle. So at 5, I'll put my closed circle. It is once again less than. Notice which way the symbol is pointing. It's pointing to the left, and it's making that less than symbol from the number line here. Shade all of that in. Okay, so now in my set of numbers, I'm looking for any number that is less than or equal to 5. So it can include 5 this time. So looking to the set, 0 is less than or equal to 5, 1 is less than or equal to 5, 4 is less than or equal to 5, and 5 is less than or equal to 5. So that would be all of the numbers that would be included in the set. So things to look out for is you have to make sure you're paying attention to which symbol, whether it be equal sign, less than or greater than, less than, greater than, or greater than or equal to. We want to look for all of those. If it is not having a line underneath it, it's an open circle. If it has a line underneath it, it's closed circle. And the symbol should be an indicator of which way to shade.